Alright, so this is 12.2, and this is all about recognizing natural exponential functions. So let's read this. It says a special type of exponential function that occurs often in application is called natural exponential function. Okay, so it's expressed as e to the x. Okay, so the base e is a special number in mathematics similar to pi. And so the number pi is approximately 3.14, whereas the number e is approximately 2.72. The number e is named for the great Swiss mathematician Euler, and most calculators have a special key that can be used to compute the natural exponential function. So if you go to your calculator, the e is right here. So you have to hit the second button and then the division button, and you get it. Now if you hit enter, you will get that value. So it's more exact on the TI than what they're giving you here, but they just rounded it, what they did. So natural exponential function takes on this form, f of x equal e to the x, where this is the value. So take a look at the example. So e to the x is the blue line here. And so if we're comparing it to other exponentials that we've done, such as 3 to the x or 2 to the x, it's in between those two. And that makes sense because it is 2.7. So that's why it's in between there. So natural exponential function is frequently used to model continuous growth and continuous decay, just like all the other ones. So we still have c times e to the rx, where if r is greater than 0, it means positive numbers, it's a growth. And then r is less than 0, which means they're negative numbers because it's decay. And so that's a point that you need to see there. So if we go to the next page, here's another modeling example. Okay, in 2013, the population of Texas was 26.5 million people, and it was growing at a continuous rate of 1.8% per year. So the population in millions per year after 2013 can be modeled by this equation. So we have our start number of 26.5, and then we have our basically our interest in decimal form, and then we just have to know what year we want to do it in. So in 2017, okay, if we're going to estimate from 213 to 217, that's why we get 4. And so you do the multiplication and take it to the e power, and then multiply last to get the 28.5. So let's do problem 105. So that is on page 838. So let's go to 838. And we'll do it for Nevada, so 103. So Nevada's population is 2.7, and they say the interest rate is 1.4%. So let's go ahead and go to my drawing board for that. So we're going to do problem 103. Okay, and again, Nevada. This is for Nevada. Anybody from Nevada? I have a daughter there. Anyways, population is 2.7 million. Okay, and the increase is about 1.4%. So we're going to change it by moving decimal place 2 places. So that's 0.014. So part A wants to have us write the equation of f of x equal to p e to the rx. So we're going to have f of x, oops, we're going to have f of x equal to 2.7 e to the 0.014 x. And now they want us to estimate for 2020. And it started at 2010. So the difference here is 10. So we'll put that in. So f of 10 equals 2.7 e to the 0.014 times 10. Okay, so let's go ahead and calculate that. So I'm going to go to second E. Oops, I always hit the wrong one. So second E, and then I'm going to go to the power of 0.014, multiply that by 10, okay, and hit enter. Okay, now I'm going to multiply it by the 2.7. So multiply by 2.7, and so I get 3.1. So basically I have 3.1 million people in 2020. That's for the f of 10. And that's how you do these problems when you're doing these types of problems that are involving natural exponential functions.